Okay, so I will talk about how to use GPUs with Python. And that is mainly I will talk about how you allocate GPUs at the different centers. So, I mean, what is GPU acceleration? How do I enable GPUs with CUDA in Python code? And how do I deploy it on GPUs at the centers? And that is the part I will mainly look at now. So, I have a few picture here that are taken from the old Broadwell node on SPC2N on Kebnekaise. I'm using it to show the layout of a generic CPU architecture. And that is compared to a GPU architecture. This is from the old NVIDIA K80. So you can see that this has a number of cores, each with some cache, but there is a lot of single precision cores on a GPU engine compared to what there is on a CPU. So it's a different type of programming that needs in order to access this. So each of them cannot do very much, but there is a lot of them. And if you have, say, a CPU, then the GPUs will be connected to the CPU on usually there is one or two GPUs on a CPU. So in this case, there are two, and they are connected each to one of these so-called Numba islands. And Numba islands are just a way of dividing up a CPU. So where they have some shared cache and shared memory within also. So. And I guess one more thing to say about CPUs and GPUs is how to look at the performance in two quantities, the latency and the throughput. So the latency is the time spent in a sole computation, whereas throughput is the number of computations that can be performed in parallel. And when we look at it that way, we can say at CPUs usually have low latency. They can do fast computations, but they have low throughput because they can only do few computations simultaneously. With GPUs, the latency is high and the throughput is also high. So you can look at it as a road where on the CPU there are more of a compact road. There are only a few cars, but they go very fast. Where on a GPU, there is a broader road, there is lots of cars, but they are slow, all of them. So, but there are so many of them that anyway, they will get more done. Of course, if your code is written to be able to handle it. And not every Python program is suitable for GPU acceleration. GPUs process the simple functions rapidly, and they are best suited for repetitive and highly parallel computing tasks. Originally, they were designed to render high-resolution images and video concurrency, and to do that fast. But since they can perform parallel operations on multiple sets of data, they are also very good at other non-graphical tasks. It's commonly to use them for machine learning and scientific computations, and also other high-performance computing in general. In any case, anywhere where GPUs can take advantage of the massive parallelism. Many of these Python packages you use are not CUDA aware, but some have been written specifically with GPUs in mind. So it's worth remembering that just because you are allocating a GPU for your code, it will not automatically run on it. It needs to be code that is written to use those. And many of the packages in the modules have been done so that they can use GPUs, but many have not. So it's important to make sure you are using the right code on it. and the rate modules. So as you saw earlier, that some of them have the word CUDA in them. If you are using, for instance, NumPy and SciPy, the code, you could optimize it for GPUs by using QPy, which mimics most of NumPy. Another way of doing it is with using Numba. And I have an example here where we are going to use Numba, which sort of is NumPy, but for GPUs. And in cases where you use TensorFlow and PyTorch, these modules on the machines you log into, you will find that some of them are compiled and written so they can handle CPUs only, and others can handle GPUs. So it's important to pick the right one. But we will talk more about that. Sorry, I still have an itch in my throat. The login nodes. In general, there are no GPUs on them, or if there are GPUs, they cannot be accessed for computations, but they can be used when you compile your code, or for instance, when you are making a virtual environment. Then in order to use them, you need to either launch an interactive job or submit a batch job. And of course, the interactive job could also be through Jupyter or Spider or something. For instance, UPPMAX. In UPPMAX, the compute nodes don't have CPUs. So in order to access the GPUs, you need to use Snowy. And a useful module on Snowy is this Python ML packages for the GPUs. So if you add -GPU to it, it's the version of it that can use GPUs, and that is available on Snowy. On Rackham, there's also one that is -CPU. So that is just the same ones, but for CPUs. And you need to use this batch command, where X is the number of cards, which in this case should be 1, because there is 1 GPU on each of these nodes. So you say, I want to run on Snowy, and I want 1 GPU. On HPC2N, there is a lot of different types of GPUs, and they also considered a separate resource. So when you apply for time on HPC2N, you need to say, I also want the GPU partition if you want to use that. So you should usually ask for both the GPUs and the CPUs when you get a project there. Our project here for the course has both. It has these 7 different types of GPUs. The old K80s have been retired, but we have V100s, A40s, A6000s, L40S, A100, and H100, which are all NVIDIA. And then there are the MI100, which are AMD GPUs. And as you can see, there is a different number of cards per node on these types. So first you decide which type of GPU you want, and then you can say how many you want of them. So if, for instance, you're asking for an H100, you could ask for up to 4. But in others, you can only have up to 2. So if you are not specifying the type of GPU, then don't put more than 2 here, because all of them have at least 2. So in general, tell how many GPUs, how many cards, GPU cards, and also what type. It is possible to say, I want any of the NVIDIA GPUs. And then again, you should not ask for more than 2, since some of them have only that. There is more on this page here about this. For LUNARC, LUNARC has NVIDIA A100 GPUs and NVIDIA A40 GPUs. But those latter ones can only be used for interactive graphics works on the on-demand system. And you shouldn't send some SLURM jobs to them. I don't know if you can, but I think they will stop you if you try to. At least they said something like that on the website. So in order to use these A100 GPUs, you should add this to your batch script. So first, the partition GPU A100, and then that you want one GPU, and it's written this way on their system. And users will be charged for the entire node because nothing else can run on it at the same time. There are also A100s on the Intel nodes which can be used, and in that case you use this command instead. So on NSC, they have NVIDIA T4 GPUs, and to access those, you should use this command here. And this here is merely to assure that you get exclusive access to it, the whole node. You could also say -N1 if you wanted to. It would have the same effect according to the documentation. Okay, so I have one example here for Numba, and it is the GPU NumPy, sort of. And it's installed on some of the senders as a module. That's on HPC2N and LUNARC. On UPPMAX, it is within the Python ML packages GPU module. But on NSC, it's not installed except for a very old version. And because of that, we will use the virtual environment that already exists here on this course project here. So I will just show you where it is. So it's here. It's this one that you should use in this example here. And I will just quickly go through it here, but you should now log in, and then we will try all to run this. And the example is this one here. It is also found within the exercises, examples, programs section. Here you also have this add list py. So it's here. It's inside of the HPC Python exercises, examples, programs. Otherwise, you can copy this and put it in a file if you want to, but it's already there if you cloned it. So this is on UPPMAX, and I will try first here to run an interactive job on Snowy, mainly because it will make it easy for us to see what is going on. So I will start that, and maybe we are lucky and we get it quickly. We did. Very nice. So I will load these modules here. And then I will try and run this Python add list py. And since we are now in an interactive session where we already allocated some nodes and where we are on that node, then we are free to run it here. And I will let it run here while I will start it up on HPC2N. I could also do it interactively there, but I'm going to do it as a batch job simply to do something different on each of them. So I will go to the HPC2N section here, and here there will be a add list.sh program. I will open it, mainly because I need to check if there's something to change, and there is. On this my path here, I want to make sure I can find it. So I changed this part here to be the name I gave my directory. The rest I can leave, since here you can see it's loading the modules needed, and it's also running it. And up here, it is asking for one L40S GPU, like this. Okay, I will save it. I will submit it. And meanwhile, this ran on Rackham, or rather on Snowy. It tells us the CPU function was took this time, and the GPU function this time. So you can see the GPU was much faster. Now, let us see if we can run it on NSC, which is quite different. The Cosmos one is very similar to the one for HPC2N. But here we will need to use this virtual environment here. And that I have already added in here, so I'm sourcing that. And let's try and go into the HPC. This. And here should also be the list one, yes. And I'm going to open it and change this path here so it's correct. Again, I need to change this part here to make sure that it's in my directory. Just one moment. The only thing that should be changed is to add the name of your directory under it. And everything else should be correct. You can see here it's activating this Numba virtual environment. And that means I should be able to just run this. Okay, meanwhile, this has been submitted here. Let's see if this is running. It's pending. Let's see if it's run here. Here it has run. And it has this name here. Let's try look at it. It got unhappy for something. Let's try and figure out what it was. I have not updated this. Okay, that was my fault. Let's open it again and look at the modules. Let's see, because there was an update to the module, I believe. 313.2307. 15 number. What is which CUDA it was? I think the CUDA has been changed, namely. 1211 is now the name of it. The other one would have worked if it was the old V100s that had that installed. Let's see if this meanwhile has run. It's still pending. Okay. But I will continue while I wait for these actually to run now. Yeah, it's also pending. Okay. So there's little I can do now, but I would like to later compare how fast they ran different places. But this one you should be able to run on all the centers if you're using the virtual environment on NSC. And afterwards, there's also some exercises if we have time to do them. They are mainly another way of you will be using the same type of batch script, but here you will also, for the first one, you will need to use I think you also need MPI for Pi, and that is not installed on either UPPMAX or on NSC, which means you will need virtual environments. So so maybe this is something that we should do later, because otherwise you need to create another virtual environment. But it should work on HPC2N and it should work on Cosmos out of the box with these examples. The example for HPC2N that I wrote here is something that should be fairly easy to change for Cosmos. Just change this path here. I think it actually is already in the in this exercises examples for both NSC and for HPC2N and for UPPMAX and for LUNARC. So I think you can find the examples there. So anyway, we know that you deploy GPUs with SLURM, and you can do it interactively or you can do it in batch. And sometimes it happens sort of under the hood if you're doing it inside of the on-demand desktop or in Spider. But you will see much more of this tomorrow when we are doing the machine learning and deep learning. In general, the Numba package is handy, though maybe not so. That's more if you're writing it yourself. But the Numba package is quite good because it does the same as NumPy, but for GPUs. And there are some information here you can go and look at if you want to read more. But I think I am going to stop here and let people try and get this to run here. Because if that works, then it should not be a problem getting it to work tomorrow. And that is what you need to be able to. So I will stop my share and let's see what. I want to see what time.